All right, in this chapter, we'll learn about set notation and sets of numbers. Now, what I find is that the best way to learn about these new notations is to start straight with the example. Okay, so let's analyze each part of this example question here. So here, there's that mathematical, mathematical notation just means that in the set called A, there are these elements, right? The elements are, so let's say if this is a set A, the elements will be 1, 2, 3, and 7, right? These are the numbers in the set A. And similarly, it's saying in the set B, these are the elements. Now, let's have a look at question A, right? A and then that funny symbol here, right? A and then the symbol B. What is the symbol? The easiest way to learn about these symbols is to put them side by side, all right? Now, see these two symbols there? The way I remember this is this looks like the letter U, which is going to stand for union, right? Union means somewhat like together, all together, all together. Okay, and then this symbol here means intersection, right? It's just two meaning, intersection or union, and the U represents union, so the other one represents intersection. So intersection is like when you have two sets, so this is a set A there, you have set A and set B, the intersection is the intersection between them, literally the intersection between the two sets. And in this case, if we were to list out the set number A and B, so let's say A is 1, 2, 3, actually I'll put it over here. So 1, 2, 3, 7, and then we will have the set B here. All right, let's see. So 1, 2, 3, 7. But note that the element 3 is also part of set B. So we need to put it into the intersection of A and B. Okay, and similarly with the number 7, it's also in set B here. And so we have to put that into the intersection of A and B. And then we can list out the other parts of set B. So we've listed out 3 and 7 already. So we can just put 4, 5, and 6. So now you can see that in the set B, it actually covers all the elements, 3, 4, 5, 6, 7. And in the set A, it also covers all the elements in set A, 1, 2, 3, 7. And so the intersection between the two sets is actually, so A intersect with B is actually the set of two numbers 3 and 7. And then now union means all together. So we're saying, okay, all together, the sets A and B, how many elements are there? Well, all together, all the elements will be 1, 2, and then we just need to keep on listing 3, 4, 5, 6, and 7. So that's the meaning of intersection versus union. All right, moving on to example 2 here. It's asking us to illustrate each of the following intervals of real numbers. So just what are real numbers? Real numbers are all numbers that you can think of normally. So it includes the integers, right? It includes the integers such as 1, 2, 3, and then 0, -1, -2. Also includes rational numbers, right? So rational numbers are numbers that can be written as a fraction. So it's like 1 over 3. Which is like 0, which is roughly like 0.3 repeating, all right? And then things like 4 over 7 and stuff like that. So numbers that can be written as a fraction. And then it also includes irrational numbers. So irrational numbers are numbers like pi, where it's a non-ending number, which is 3.14, keeps on going. I'm not smart enough to remember all of the digits, but just know that pi is an irrational number. And similarly, later you will learn in math methods that the letter E, right, represents the Euler's number, and this is also an irrational number. It is a decimal number that never ends. Okay, so how do we illustrate each of these following intervals of real numbers? So let's have a look at question A here. Let's analyze the question here. All right, so there's a number on the left and there's a number on the right. This is the number on the left represents the lower limit, and the number on the right is the upper limit of our interval, right? So interval is it's like a set of numbers, right? It's just a range of numbers. And then let's have a look at this symbol here. So that square bracket as opposed to the round brackets in the next question. So a square bracket represents inclusive inclusivity or inclusive. This means that if you have a number line, right, and then you put the lower limit is 2, upper limit is 3, the range of numbers, this one means that there is a range of numbers between 2 and 3, but including 2 and 3 as well. All right, and then we join the interval by that line there. So actually I'll redraw that in red. So this is actually what you will be drawing, the red line there. Okay, from 2 to 3, from negative 2 to 3, inclusive. So for question B, from negative 3 to 4, now there are two types of brackets. That's a round brackets, that's a square brackets. Okay, that means that the lower limit will be negative 3, upper limit is 4, and the lower limit, it will be exclusive. So note that this round bracket means exclusive. So it does not include the number negative 3. All right, so from negative 3 all the way to the number 4. Right, but not including number negative 3 is represented by a hollow circle here, as opposed to a solid circle at number 4. Okay, and then moving on to question C, if you have something that has infinity in the interval, so negative infinity to positive 5 inclusive, what would this one look like? Well, let's say this is a number line. You can't actually represent infinity as a number. So the best we can do is that we start from 5 and then we draw the line, but we know that it goes on forever. So we draw the arrow saying that, okay, this interval will go from 5 and then it extends towards negative infinity. So you may ask, oh, okay, so how do we represent like the entire set of real numbers R, which is from negative infinity? So note that you can't be equal to infinity, yeah? So it's always round brackets, to positive infinity. Now this one is very simple. It's just a number line and then you just draw the two arrows here, right? Let's say this is the number 0, all right? And then you draw the two arrows. This represents the set of all real numbers, right? Basically everything on the number line goes on to infinity, to negative infinity and to positive infinity. All right, and then similarly we'll have question D is simple, so let's go to E. From 3 to positive infinity. All right, and they're both exclusive. So this one would be starting from 3 and it's a hollow circle, and then you draw the arrow to the end of the number line saying that it will keep on going forever. So this is representing the interval from 3 to infinity. And lastly, just some quick notations here. So we'll write, so for example, let's say a number for this interval here. Let's say the number 4, is this part of the interval? Yes, it is part of this interval. So how do we write that? Well, you use that symbol here, right? It's like a letter E, and then 4 belongs to the interval 3 to infinity. Okay, so that's how you write something like, so this is just saying that 4 is in the interval, interval 3 to positive infinity. And similarly, we can write something like, let's say, what's the number 2? Is that part of from 3 to infinity? Not quite. It's like somewhere over here. It's actually not part of this interval. So you write 2 is not part of the interval from 3 to infinity. Okay. Now, how about number 3? Is this part of the interval 3 to infinity? All right, we'll pause there and then think for a second. If you answered no, that is correct because it's a hollow dot, it's exclusive, right? So that's 3 is not part of the interval from 3 to infinity. Okay, but 3.001 would be, because it's still to the left of 3. So 3.001 will be part of this interval here, but not the exact number 3. Okay, so that's another pattern notation. Now there are many other notations for set and set notations, but I'll pause here and then retry these examples. When you get to the exercises, you'll be able to find more resources related to the other symbols.